Hi again, my dear students in grade 7. We are going to make our mathematics exam review worksheet, solving it together. This is for semester 2 exams. I hope you enjoy these questions and you are ready. The topics covered in this exam are the greatest common divisor and the least common multiple, GCD and LCM. The second lesson is the triangles and the remarkable lines in a triangle. The third lesson is the congruent triangles, case 1, which is the ASA, and lesson number 12, which is our fourth lesson, and the last lesson, which is about fractions, everything concerning fractions. Question number 1. We should specify whether the following statements are true or false. If the statement is true, we write T. If the statement is false, we write F. The fraction 1/8 is a reducible fraction. This statement is false because in a fraction when the numerator is 1, the fraction should be irreducible and not reducible. The median is a line from the vertex to the midpoint of the opposite side. This is true. This is the definition of the median in a triangle. If in a triangle, angle A is equal to 70 degrees, angle B is equal to 30 degrees, angle C is equal to 90 degrees, then triangle ABC is a triangle. This is wrong. Why? Because ABC to be a triangle, the sum of angles should be 180 degrees. If we add 70 degrees plus 30 degrees plus 90 degrees, it gives us 190 degrees, which is false. The LCM of 15 and 45 is equal to 45. This is true because 45 is a multiple of 15. When we have two multiples, their LCM is the greatest. The fractions 7/5 and 21/20 are equivalent fractions. The second fraction to be equivalent to the first fraction. This means we multiplied the first fraction by the same number. 7 times what gives us 21? It multiplied by 3. 5 times what gives us 20? We multiplied by 4. We here multiply by different numbers, then these are not equivalent fractions, then this is false. In a triangle, the intersection of the three heights is the centroid. This statement is false because the intersection of the three heights is not the centroid, it is the orthocenter. In a right triangle, the base angles are supplementary. Also, this is false because in a right triangle, the base angles are complementary. This means that the sum of these two angles is 90 degrees and not 180 degrees. Question number 2. We should construct a triangle EFG such that EF is equal to 6 centimeter, EG is equal to 5 centimeter, and angle FEG equals to 70 degrees. To draw this triangle, first we draw the greatest side, which is EF, 6 centimeter. Then we assign the angle at the vertex E, which is 70 degrees. We join the assigned angle with the vertex E in a side which is equal to 5 centimeter, and we will get our triangle EFG. Now we should draw in part A the bisector of angle FEG. FEG, this means at the vertex E, the angle is 70 degrees. To draw the bisector, we divide 70 degrees by 2. It gives us 35 degrees. This means that we will get two angles. Each angle will measure 35 degrees. And we draw this bisector using the protractor. The median issued from F. If I wanted to draw the median issued from F, I should know the opposite side to F. The opposite side to F is EG. So before I draw the median, I should know the midpoint of EG. With the long ruler, we measure EG, which is 5 centimeter, and we divide the measure by 2. So we assign the midpoint at the 2.5. Then we bring the long ruler and we join the midpoint with the vertex, which is F, and we get the median. Now in part C, we should draw the height relative to EF. To draw the height relative to EF, we use a set square. We put the set square on EF and we draw a perpendicular from G to EF. We get the perpendicular, and now the perpendicular bisector of segment EF. The measure of segment EF is 6. We divide 6 by 2 to get the midpoint of segment EF. At the midpoint, we put the set square and we draw a perpendicular line. This is the perpendicular bisector of segment EF. The marks of the bisector, the median, the height, the perpendicular bisector are very important to be put on the figure. Question number 3, we should find directly the GCD of 15 and 60. The GCD of 15 and 60, because 60 is a multiple of 15, then the GCD of 15 and 60 is the smaller number, which is 15. To find the LCM of 15 and 60, the LCM, because they are multiples, the LCM is the biggest number, which is 60. Now the GCD of 25 and 26, we can see that the 25 and the 26 are relatively prime numbers, then their GCD is 1, because 25 and the 26 are relatively prime, or they are successive numbers. Now, how can we deduce the LCM of 25 and 60? We have a rule, which is that GCD times the LCM of two numbers is equal to their product, which is 25 times 26. Now, if we substitute the GCD by 1 times LCM equals 25 times 26. 1 times LCM gives us LCM equal 25 times 26. The product of 25 times 26 is 650. So the LCM of 25 and 26 is 650. Now in part B, we should use the method of prime factorization to find the GCD and LCM of 225 and 1000. 225, we can divide it by 2. No, we can divide it by 3. If we divide 225 by 3, it gives us, by 3, it gives us 75. If we divide 75 by 3, it gives us 25. If we divide 25 by 5, it gives us 5. If we divide 5 by 5, it gives us 1. So the prime factors of 225 are 3 times 3 times 5 times 5, which means 3 squared times 5 squared. The prime factors now of 1000, if we divide 1000 by 2, it gives us 500. 500 by 2, it gives us 250. 250 can be divisible by 2, it gives us 125, cannot be divided by 2 or by 3. We can divide it by 5, it gives us 25. 25 by 5, it gives us 5, and 5 by 5, it gives us 1. So the prime factors of 1000 are 2 to the power 3 times 5 to the power 3. Now we should find the GCD of 225, GCD of 225 and 1000. In GCD, we choose the common factors with the less power. Here we have 3 is not common and 2 is not common. 5 is a common factor. We take the less power. 5 squared is equal to 25. Now if we want to find the LCM of 225 and 1000, we take 2 cubed times 3 squared times 5 cubed. Now I have 4 times 9, it is 4 times 9, it's 36, and we have, so here the answer is 9000. The LCM is 9000. Now we should deduce that the number 225 is the square of a number to be determined. The prime factors of 225 are 3 squared times 5 squared. We take the prime factors 3 times 5 and we write outside squared. 3 times 5 is 15 squared, so it is the square of 15. Now we should deduce that 1000 is the cube of a number to be determined. Also we write the prime factors of 1000. We take the prime factors and outside we write cube. 2 times 5, it is 10 cubed. In part 5 we should verify that 225 times 1000 is equal to LCM times GCD. 225 times 1000 is equal to 225 and we add 3 zeros. If I want to multiply the LCM by the GCD, the LCM is 9000. I should multiply it by 25. It gives us 225000. Then we can see that 225 times 1000 is equal to the LCM times GCD. Question number 4, we should write the given of the coded figure. To write the given, we should look carefully to the figure we are given. We can see that given an angle, we are drawing an angle XOY. XOY is equal to 70 degrees, and we have drawn, we trace OM, which is a line which is the bisector of angle XOY. We can see that angle MOX is equal to 35 degrees and angle MAO is equal to 90 degrees. Now in part B, what's the nature of triangle OMA? Triangle OMA is right. Why? Since angle A is equal to 90 degrees. Now we should calculate angle OMA. We have OMA plus OAM plus MOA is equal to 180 degrees, sum of angles in a triangle. OMA is the missing angle plus OAM is equal to 90 degrees. MOA is equal to 35 degrees equal to 180 degrees. Now angle OMA plus 125 degrees is equal to 180 degrees. Angle OMA is equal to 180 degrees minus 125 degrees. So angle OMA is equal to 55 degrees. Now, given this figure in part B, what's the nature of triangle ECA? If we look at the triangle ACA, triangle ECA, we can see that M is the midpoint of CA and EM is perpendicular to CA. Then line EM is the perpendicular bisector of segment AC. Then E is equidistant from A and C, means that EC is equal to EA. Then triangle ECA is isosceles of vertex E. It's an isosceles triangle of vertex E. Now we should calculate angle ACB. In triangle ABC, angle ACB plus angle CAB plus angle ABC, sum of angles is equal to 180 degrees. Let's substitute Angle ACB is missing. Angle CAB is 40 degrees. Angle ABC is 90 degrees equal to 180 degrees. So angle ACB plus 130 degrees equal to 180 degrees. Angle ACB equal 180 degrees minus 130 degrees. Then angle ACB is equal to 50 degrees. Reduce in question number 5 the following fraction first by method of successive division. The fraction is 840 over 900. We can divide up and down by 2, so we divide by 2. 840 divided by 2 is 420, and 900 divided by 2 is 450. Also, we can divide both factors or both terms by 2. 420 divided by 2 is 210. 450 divided by 2 is 225. We can divide the numerator by 2, but the denominator cannot be divided by 2. Who's successive to 2? We can divide up and down by 3 because the 3 is a common factor. 210 divided by 3 is 70, and 225 divided by 3 is 75. Now we can't divide by 3 anymore, so we divide up by 5 and down by 5. 70 divided by 5 is 14. 75 divided by 5 is 15. 14 over 15 is an irreducible fraction because 14 and 15 are successive or relatively prime. Now we should find the GCD of 840 and 900 by method of prime factorization. 840 divided by 2 is 420. 420 divided by 2 is 210. 210 divided by 2 is 105. 105 divided by 3 is 35. 35 can be divided by 5. It gives us 7, and 7 divided by 7 gives us 1. So the prime factors of 840 are 2 cubed times 3 times 5 times 7. Now the prime factors of 900. Divided by 2, it gives us 450. Divided by 2, it gives us 225. 225 divided by 3, it gives us 75. 75 divided by 3, it gives us 25. 25 divided by 5 is 5, and 5 divided by 5 is 1. So the prime factors of 900 are 2 squared times 3 squared times 5 squared. Now we should find their GCD. GCD of 840 and 900. We have 2 cubed and 2 squared. The least is 2 squared. We have 3 and 3 squared. We take 3. 5 and 5 squared. We take 5. 7 is not common. We don't take it. Now 2 squared times 3 times 5. It gives us 60. We divide both terms of the fraction by 60. 840 divided by 60, it gives us 14. 900 divided by 60, it gives us 15. Now we should divide 840 over 900 by the method of prime factors. We substitute the prime factors of 840. The prime factors of 840 are 2 cubed times 3 times 5 times 7. The prime factors of 900 are 2 squared times 3 squared times 5 squared. Now we cancel 2 cubed and 2 squared. 2 remains up because it's of the greatest power. 3 and 3 squared, 3 remains down. 5 and 5 squared, 5 remains down. And 7 remains up. 2 times 7 is 14. 3 times 5 is 15. 4 over 15 is an irreducible fraction. Now we should give the equivalent fraction of 99 over 555 whose denominator is 100. To obtain a fraction equivalent to this and whose denominator is 100, we try to reduce this fraction. We can reduce up by 11, down by 11. It gives us 9 over 5. Now 5 can be changed into 100. How? We multiply both terms by 20. 9 times 20 is equal to 180. So 180 over 100 is equivalent to 99 over 55, and of denominator 100. In question number 7, we should complete these fractions because these are equivalent fractions. 13 over 9 equals how much over 72? 9 becomes 72 because it increases, so we multiply down and we multiply up. 9 times 8 gives us 72, so we multiply up by 8. 3 times 8 is 24, 4, 2 in hand. 8 times 1 is 8 and 2 is 10, so we get 104 over 72. Now we have 240 over 360. 240 became 24. It decreased, so we divide up, we divide down, we divide by 10, so we divide by 10. 360 divided by 10 is 36. 36 becomes a 3. It decreased, so we divide by 12 up, 12 down. 24 divided by 12 is 2 over 3. Now 333 over 555 equal how much over 5? 555 became 5, so we divide by 111. So up we divide by 111, it gives us 3. Now, how much over 90 equals to 3 over 5? 90 became 5. How did 90 became 5? We divide by 18. So up we divide by 18. A number divided by 18 gives us 3. Move in an inverse way. 3 times 18 gives us the answer, so it is 54. Now 648 over 720 equals 324 over how much? Here we divide by 2, so down we divide by 2, it gives us 360. 360 we divided by 2, so up we divide by 2. 324 divided by 2, it is 162. 162 becomes 81. How did it become 81? We divide by 2, we divide by 2. Here the answer is 90. 90 became 30. We divide by 3, so 81 we divided by 3. It gives us 27. 27 is divided by 3 to give us 9, and 30 is divided by 3. It gives us 10. These are equivalent fractions. In question number 8, let M and P be a right triangle at M. This means that angle M should be equal to 90 degrees and such that MN equals 5 centimeter, MP equals 3 centimeter. With a long ruler, we draw the side MN. Then using a protractor, we assign at angle M the 90 degrees. We join this assigned angle with the vertex M in a line equal to 3 centimeter. In this way, we get a triangle MNP right at M. Now we should draw the bisector of angle NMP. To draw the bisector, we divide the measure of the angle by 2. So we divide 90 divided by 2. It's equal to 45 degrees. And we draw the bisector of angle M. This bisector cuts the side MP at a point S. Now let E be a point of MN. We should put E on MN such that angle MSE should be equal to angle MSP. We measure the angle MSP and we draw an equal angle which is ES. Now prove that the two triangles ESM and MSP are congruent. To prove congruent triangle, first of all, we should say that in triangles, we should name them ESM and MSP. What do we have? First, we can see that between these two triangles, we have a common side, which is MS. So MS is a common side. On this side, we should see the adjacent angles. We have angle EMS is equal to angle SMP because MS is the bisector, so this are equal by given. And we have the other adjacent angle ESM, angle ESM is equal to angle MSP. These two angles are equal also by given. Now we can say that triangle ESM and MSP are congruent by ASA. After proving that these two triangles are congruent, we should name the homologous elements. The homologous elements means what are in these two triangles the equal sides and the equal angles. We have a remaining angle, which is this angle MES will be equal to angle SPM. These two angles will be equal, and we have side EM will be equal to side MP, side ES will be equal to side SP. These are the homologous elements. Now we should draw ES will cut MP at a point T. They will intersect at T. We should prove that triangle SPT and the triangle SEN are congruent. We say now in triangles SPT and SEN, what do we have in these two triangles? We have side PS is equal to side SE. This is proved in the homologous elements in the first part. Angle TSP is equal to angle ESN. These are vertically opposite angles. They are equal. Angle SPT is equal to angle SEN. Since angle SPM is equal to angle SEM, then we can say that the triangle SPT and SEN are congruent by ASA. Now we should name the homologous elements. What are the homologous elements in these two triangles? First, side ST will be equal to side SN, side PT will be equal to side EN, angle PTS will be equal to angle ENS. These are the homologous elements. In question number 9, we should perform operations on fractions. Here we have addition of like fractions, denominator 9, 2 plus 4 is 6. 6 over 9 we can reduce up and down by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. 5 over 10 minus 1 over 10, also we have like fractions, denominator 10, 5 minus 1 is 4. We can divide up and down by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Here we have unlike fractions. We change them into like. We can see that 6 is a multiple of 3. How can 3 become 6? So we multiply this fraction directly by 2. Here we have 4 over 6 plus 5 over 6, like fractions, it's 9 over 6. We reduce up and down by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Now in part D, we have 1 over 2 minus 4 over 5. We multiply the first fraction by 5 and the second fraction we multiply it by 2. 1 times 5 is 5. 2 times 5 is 10. 4 times 2 is 8. 5 times 2 is 10. Denominator 10. 5 minus 8 is minus 3. Here we have division of fractions. We change division into multiplication times 31 over 23. We write them on one fraction. 23 times 31 over 31 times 23. We reduce by 23, it gives us 1. We reduce by 31, it gives us 1. 1 over 1 is equal to 1. Here we should apply rules of order of operation over 1. So it's equal to We change them into like fractions. Times 1 times 1 times 5 times 5. 3 over 5 plus 10 over 5 divided by 8 over 3 equals 13 over 5 divided by 8 over 3. We change them into multiplication. 13 over 5 times 3 over 8. This is equal to 39 over 40. Here we have multiplication of fractions. We write 8 times 20 over 15 times 12. But divide by 5 is 3. We divide by 5 is 4. Now, if we divide by 4, it's 1. If we divide by 4, it is 3. 8 times 1 is 8, and 3 times 3 is 9. Also multiplication of two fractions. 25 times 24 over 44 times 55. By 5 it gives us 5. By 5 it gives us 11. By 4 it gives us 6. By 4 it gives us 11. 5 times 6 is 30. 11 times 11 is 121. Here we apply rules of order of operation. We start with this parenthesis. So we write 5 plus 3 times 8 minus 6 times 5 over 3. We change division into multiplication. Plus 14 minus 2 squared equal 5 plus 3 times 8 minus, on one fraction, 6 times 5 over 1 times 3 plus 14 minus 2 squared equals 5 plus 3 times 8 minus, here we reduce by 3 2, by 3 is 1, 2 times 5 is 10, plus 14 minus 2 squared. 5 times 3, sorry, 5 plus 3 times, now order of operation, this is the strongest, 8 minus 10 plus 14 minus 4 equal 5 plus 3 times order of operation. 8 minus 10 is minus 2 plus 14 minus 4. Now minus 2 plus 14, 5 plus 3 times 12 minus 4. Now 5 plus 3 times 8, order of operation. 5 plus 24, this is equal to 29. Hope you enjoy this worksheet solution, and best of the best in your exams.